Hello friends, myself Pratibha Rondal, Department of Chemistry of KAANMS SCS College, Satana. Today I am going to discuss about the terpenoids. Today we discuss about the definition of terpenoids, isolation of terpenoids, isoprene rule, classification, general methods of structural elucidation, then structural elucidation, citral and menthol. Terpenoids are the hydrocarbons of plant origin of general formula C5H8N as well as their oxygenated, hydrogenated and the dehydrogenated derivatives. Terpenoids are the hydrocarbons and the origin of terpenoid is the plant origin. Terpenoids is originally the term terpene was employed to describe a mixture of isomeric hydrocarbons of the molecular formula C10H16 occurring in the turpentine and many essential oil which are obtained from the sap and the tissue of certain plants and the trees. The oxygenated derivatives like the alcohol, aldehyde, ketone at that time called as a camphor. That terpenoids are originally that the term is the terpene. This is the isomeric hydrocarbons of molecular formula C10H16. Then the classification of terpenoids, the first is the isoprene, then monoterpene, then sesquiterpene, diterpene, triterpene, tetraterpene and polytetrene. Here the number of isoprene unit in the isoprene is the 1, in monoterpene the number of isoprene unit is 2, in sesquiterpene number of isoprene unit is 3, in diterpene the number of isoprene unit is 4, in triterpene the number of isoprene unit is 6, in tetraterpene the number of isoprene unit is 8, and in polytetrene the number of isoprene unit is n. Here when we see the molecular formula of isoprene is the C5H5. In monoterpene here the molecular formula is C10H16. In sesquiterpene here the molecular formula is C15H24. In diterpene the molecular formula is C20H32. The molecular formula of triterpene is C30H45. In tetraterpene the molecular formula is C40H64. In polyterpene here the molecular formula is C5H8N. This is all about the classification of terpenoids. That means it starts from the isoprene unit. This is the example of terpenoids. This is the geraniol, citranilol and farnesol. This is obtained from the rose flower. This is the second picture is the limonene citral, that terpenoid which is obtained from the lemon. Then next terpenoid is the eugenol oil that is obtained from this one. This is all about the examples of terpenoid which is obtained from different plants. Then see here the physical properties. Terpenoids are the colorless liquid that is soluble in organic solvents and which is insoluble in the water. Most of the terpenoids are optically active. The terpenoids are volatile in nature. The physical constant, that means the boiling point of terpenoid, is in the range of 150 to 180 degrees Celsius. Then next is the chemical properties. That means they are unsaturated compounds. They undergo the different reactions like the addition reaction with the hydrogen, halogen acid to form the addition products like the NOCl, NOBr and hydrates. They undergo polymerization reaction, dehydrogenation reaction in the ring. On the thermal decomposition, terpenoid gives the isoprene as the one of the product. This is the chemical properties of terpenoids. This is the very much important rule in the terpenoid. The name of the rule is isoprene rule. In 1887, Wallach proposed the rule. The name of the rule is isoprene rule. The isoprene rule states that the skeleton structure of all terpenoids are built up of isoprene unit, or that isoprene unit is also called as a 2-methyl 1,3-butadiene. Here CH2 double bond CH CH3 single bond CH double bond CH2. This is the structure of 2-methyl 1,3-butadiene. This is also called as the isoprene unit. This is the isoprene rule. The isoprene rule is derived from the following facts. The empirical formula of almost all terpenoid is T5H8. The thermal decomposition of all terpenoids gives isoprene as one of the product. Example here, the rubber on destructive distillation yields the isoprene as the product. Here the special isoprene rule is proposed. This rule is proposed by Ingold in 1925. According to this rule, the isoprene unit in terpenoids are joined by head to tail linkage or head to tail manner or 1,4 linkage. The branch end of isoprene unit was considered as head and other end as a tail. Here the H for head and T for tail. Here by using the head tail position, there is a formation of here the structure or the molecule. This is the classification of terpenoids. This is we already see in the previous slide. The terpenoids have the general formula C5H8N. Based on the value of N, the terpenoids are classified into the different factors, different points. Here the 5, 10, 15, 20, 25, 30, 40, greater than 40. This is the number of carbon atom. On the basis of the number of carbon atoms, here the isoprene, here the classes are generated: hemiterpene, that is also called as the isoprene, then monoterpene, sesquiterpene, diterpene, sesquiterpene, triterpene, tetraterpene and polyterpene. Here the molecular formula is also mentioned for every class for the number of carbon atoms. Here the value of n is variable for different classes. Terpenoids are classified based on the number of rings present in the terpenoids. Acyclic terpenoid, monocyclic terpenoid, bicyclic terpenoid, tricyclic terpenoid and tetracyclic terpenoids. This is all about the terpenoids classification, which is based on the number of rings which are present in the terpenoids. This is the monoterpenoids. Here the acyclic ring is there, that's why the name of the monoterpenoid is acyclic. This is the example of citronellol. Here the carbonyl group is there, but that ring is acyclic. In this cyclic ring is not there, so this is the acyclic monoterpenoid. This is the second example of citral which is present in the lemon. Thank you.